The History of the Atom Part 2 by Madison and Christina.
Before the Rutherford and Bohr model was J. Thomson's model in 1911. This was known as the plum pudding model. He thought that the positive protons and the negative electrons were uniformly mixed throughout the atom. He tested this by doing the gold foil experiment. Rutherford was the one that tested it because he wanted to see if this model was true or false. He said if Thomson's model was correct, then the mass of the atom would also be spread throughout. If he shot a high-velocity alpha particle at an atom, then it couldn't deflect the alpha particles. Using this experiment, he used a thin gold film of atoms as the alpha particles, and most particles went through the gold sheet, but some reflected back. This proved him to be wrong. He was forced to get rid of Thomson's plum pudding model and thought the only way the particles could deflect is if most of the mass were in a nucleus. He developed the planetary model, and it gets its name because it's similar to the planets around the sun and electrons orbit around the nucleus. Bohr's theory that electrons existed in orbits around the nucleus was a key to periodic repetition of properties of elements. He joined Rutherford in 1912. Bohr realized that Rutherford's model wasn't correct and decided that atoms shouldn't be stable. He said that the electrons orbiting should give off energy and spiral down to the nucleus, but it does not do that in the model. This should also cause the atoms to collapse, or the electrons could be knocked out of position if a charged particle passed by. To explain stability, he turned to Planck's quantum theory, which is the ratio of energy and electrons to frequency of it orbiting around the nucleus, which is equal to Planck's constant, 6.626 times 10 to the 8th. Bohr concluded that electrons jump between energy levels in quantum state, and quantum state is when electrons absorb energy, give off light or heat. Electrons should jump either higher or lower orbits. Electrons in the Bohr model lined up with a regular pattern of light emitted by a real hydrogen atom. Bohr's theory included shells that have different quantum numbers and only hold a certain amount of electrons. Others refined Bohr's model as time went on. His atomic model was the key foundation to the quantum mechanics.
Planck came up with the original quantum theory. Quantum is the minimum amount of energy that can be gained or lost by an atom. He looked at color changes from energy and realized he could explain the color changes if he assumed that the energy of a body changes only in small units. Later on, he created an equation to help with his theory, which was E equals h times v. The energy of quantum equaled hv, and h was 6.626 times 10 to the negative 34. Einstein discovered that light could be described as a particle, but the atom was to be composed of a nucleus of protons and neutrons, orbiting shells of electrons. He discovered that light energy can be absorbed or transferred in small packets called quanta. He explained the equivalent of mass and energy expressed by the famous equation E equals mc squared. Bohr discovered that the atom is a small positively charged nucleus surrounded by orbiting electrons. Bohr was the first to discover that electrons travel in separate orbits around the nucleus and that the number of electrons in the outer orbit determines the properties of an element. The two guys discovered the quantum mechanical model in 1926. They figured that electrons are called orbitals and not orbits, and the location cannot be pinpointed. Electrons are particles and waves at the same time. They developed quantum numbers based on theories of Einstein and Planck. Thank you for watching.